Now, the key between these two formulas, which I'm 90% sure we don't give to you, but I will check and let you know tomorrow, is if you have an n value, notice that this first formula has, you have to divide it by n. That's your compound frequency. So if it says annually, semi-annually, quarterly, monthly, oh, it should be a weekly in there too. There should be a space. How many weeks are in the year? So if it's weekly, that would be n equals 52. I didn't realize that monthly and weekly were together. There's no such thing as monthly, weekly. So if it's monthly, it's 12. If it's weekly, it's 52. The only time you use the green, per, does anybody remember from Algebra 2? What's the key word? Begins with a C. Continuously, yep. If it says it's compounded continuously, that is when we use A equals P, e to the power of RT. We remember this from Algebra 2? All right, so you do need a calculator for this section. So let's look at example 1. It says you deposited $5,000 into an account. So that's my starting balance. So P is 5,000 into an account that pays 2% annual interest. So R is 0.02. You always change your percent to a decimal. Because when we're talking about a percent is always over 100. So if you take 2 divided by 100, you get 0.02. It's compounded monthly. So what is N going to equal? 12. We want to know how much money will be in your account after 4 years. All right, so to figure that out, we're going to set it up. A equals, you got $5,000. 1 plus, hit your fraction. And then you have your rate at the top over 12. And that's raised to, hold on, I need some more space. All right, that's raised to the power of n times t, which is 12 times 4. So go ahead, take a moment. And now we're talking about money, right? So when we talk about money, how many decimals do we use? 2. Everything is to the hundredths place when we talk about money. Okay. And if you need help, so I'm gonna tell you what I got. 2% is not a lot. That's not a high interest, but make sure you got what I got. I got $5,416.07. Who got that? Yay. Means I typed it in right. All right, let's go to our next one. You didn't get that in there? Okay. Okay, so you have to hit the exponent key. So, yeah, this is an exponent. So you have to delete that and not hit the exponent. Yeah, well. Yeah. So when we talk about a percentage is out of 100. So we would divide that by 100. Anytime you have a percentage, to convert a percentage to a decimal, you divide by 100. Good question. All right, let's look at example 2. We doing these together because I don't really know the answers to these, so we're gonna kind of just see what we get. So example 2, now we have $5,000, 2% annual interest, but we got that keyword continuously. How much money after 4 years? So because of that word continuously, now I'm using this formula. So I'll give you all a second to see what you get. So this time my starting value is $5,000. Well, it's $5,000 again. My rate is still 2%, and T is 4 years. So we're just gonna type that in and see what we get. Now, continuously should always give you the highest amount of money. So whatever you get should be close to what we got for example 1, but a little bit higher. So you got to hit the second function ln now to get in the E. So the difference is just a matter of cents. That's the difference between example 1 and 2. So it's not that big of a difference between continuously and monthly. So for this one, you should get, for your final answer, $5,416.44. Who got that? All right, let's keep going. Now let's talk about student loans. All right, so Jacob graduated college with $45,000 in student loans. His loans are in an account charging 6.7% interest compounded annually. So compounded annually means N is 1. If he doesn't make any payments after 1 year, how much debt from student loans will Jacob have? So if he doesn't make any payments, so we have 2 different questions. The first one is asking how much debt after 1 year. The second one is saying after 5 years. So we have to do this twice. So we start off with $45,000 in student debt. Now again, you want to take that 6.7, divide that by 100. So 6.7 divided by 100. I know, 6, 7. Man, I didn't think about that. 6, 7. Wow. So, so that's 0.067. And then the first time, T is 1. Okay, so whenever N equals 1, we can actually use a little bit of a modified formula, but I don't want to confuse you all, so I'm not going to even talk about that. So it would be A equals 45,000, and then it would be 1 plus 0.067 over 1 to the power of 1 times 1. So I don't know if you all realize what I was going to say. Because this is 1, we didn't have to put that as a fraction. I just didn't want to confuse nobody. Because again, we just got. So go ahead and calculate, see what you get. This is after 1 year. And then we're going to do it again to see what it would be after 5 years. Now the second time, T is 5. So again, you didn't have to make it a fraction, but I'll just, and then this is to the power of n times t. So go ahead and see what you get for after 1 year. What's his debt? After 2 years, what's the debt? So again, this is assuming no payments were made. So it was just earning interest. So that is what I got. Who agrees with my two answers? So after 1 year, it was about a $3,000, and but then after 5 years, that was a big difference. What's that, about 17,000? What's 62 minus 45? Is it 17? Yep. All right, any questions about our first 3 examples? So far, nothing's complicated. All right, let's keep going. So now we got example 4. So this says that at 1.15% annual interest compounded monthly, how long will it take to double your money? So notice that they didn't give us a starting value or ending value. All right, so that means that we can pick any number we want to start, because it doesn't matter the amount of money we start with. It's going to take the same amount to double it. So if I'm trying to double $1 to $2, or $100 to $200, or $5 million to $10 million, the amount of time will not change. So it doesn't matter what you choose for your starting and your ending value. So for my starting value, I'm just going to pick $1. I mean, why go big? Let's go small. So if I start with $1, and if I want to double it, that means I'm ending with how much? $2. Again, I want to make sure, because somebody's going to say, how did you pick 1 and 2? You can pick any number for P as long as A is doubled it. Okay? So you don't have to pick 1. You can pick whatever. You can pick 25 cents, double it to 50 cents. I just like to make it simple. I use 1 and 2. Okay. Compounded monthly, so that means N is 12. Our interest rate, when you take that 1.15, take the 1.15, convert that to a decimal, you get 0.015. And now this is what I'm trying to find, is T. So because it's compounded monthly, I am using this formula. All right, so let's go ahead and substitute all my variables in. So I have 2 equals, and then I don't have to put the 1 because that's just, 1. Then I have my parentheses, 1 plus. My interest rate is 0.015 over 12. That's to the power of 12 times T. Yes. What is it? What should it be? 0.11. I should have 2 1s. Thank you. Thank you for saying something before we got too far. 115. 115. Okay. So are we good now? Does that look good? So I'm trying to solve for t. So, all right. RT is an exponent, right? So we learned yesterday, what do I need to put in on both sides in order for the exponent to come down? A log. Now, we don't have a log with that base. So does it matter which log we use? We can use a common log or a natural log. Which one do you want to go with? Common log. So I'm going to put in a common log on both sides. When I do that, it's simply going to move this to the front. So what it's going to give me is log of 2. I'm going to just put that in parentheses. Equals 12t log of that big ugly parentheses. So this is where we have to do some really fancy calculator work. But our calculator can do it. It can do it. Okay. Do you see where that t is? That t is in the middle of two things that is being multiplied by. So the t is being multiplied by 12, and it's being multiplied by this number. These are two different numbers that are multiplied by t, and I want to get t by itself. So what I'm going to do is divide both sides by what you see I have boxed. So in my calculator, I'm going to type in log of 2 divided by 12 times the log of that parentheses. Make sure that this is all under the fraction. So it's pretty ugly. Type it in just like that. So you have a fraction, and then you have another fraction in your denominator. I know, I'm tired too. And this coffee, oh, you even got Starbucks, and you still tired? Man. I wish I could get my life together enough to go to Starbucks in the morning. I'll be fighting for my life trying to get out the door before those buses, though. I don't have time. Then I'm going to hit another fraction, 0.0115 over 2. I know, so it's a lot that we got to type in, but your calculator can do it. It can do it. It doesn't tell me where to round to, so for this one, I'm just going to round to the 10th place. It didn't tell me, so I'm going to say t, and on the test, it will tell you where to round, okay? So if you typed it in correctly, you should get 10.1 years. Wait, hold on. Let me make sure. Wait. People saying no, so I got to look at what I did. Hold on. That's what you got? You did not get that. Okay. So.
Yeah, they don't say 60. Wait, I think you put, how did you get 2 at the bottom with a fraction?
It should be a 12. It should be a 12. I did that on purpose, y'all.
No, you did not.
Yes, I did. Because I was like, man, when I don't agree with Maya, I feel like I don't feel confident. Yeah. If Maya say, then I'm like, ooh, I messed up. 60 years. Oof. Well, the interest rate is 1.15, so that's pretty bad. So 60 years. Oof, that's horrible. So lesson learned, don't invest in something with a 1.15% interest rate. All right, so we're going to end there for today. Tomorrow, again, we have our skills check. Our skills check is going to cover 5.5, and you do have one equation where you have to do a property. So remember, addition, how do you condense addition? Multiplication. And subtraction, division.